Okay, hey, 20-2. So we're going to start doing some word problems with 6.3. So it's still in unit or in lesson 6.3, but now we have to kind of pick out the information. So I'm going to walk you through this first one. This one's a typical question about maximizing area. So a typical question might be, so the actual question's in your textbook, but it says read the short paragraph on page 337 about Atanek and his kennel for his dog team. It is very important to notice that he only has 40 meters of fence of kennel, no more, no less. The question we're trying to answer is what dimensions should that person use to maximize the area of the kennel. So we got the kennel on the side of the house over here, and we only have 40 meters of fence to do this side, and that side. That's kind of what we're saying. So the first part here, it just kind of walks you through the steps of this thing. It says, instead of answering the text questions, answer the below questions. So the ones I have here kind of help you out a bit, kind of we go step by step. So it says, if the kennel were to be 5 meters wide, so it's saying if this side was 5, how long would it be? What would this area be? So if this was 5, that would also mean that, maybe I won't put meters, 5 meters to make things confusing. So that's 5, and it's saying what would its area be? So if we made a little equation of this, I'm going to call this side y for now, just any variable, right? But I can make an equation of this. I can say, well, if I wanted to put all the info in, I'd say, well, this side, 5 plus the 5 up there plus my y. So 5 plus 5 plus y. I know they all have to be equal to 40. That's all the fence I have, right? If I simplify this a little bit, I can call 5 plus 5, that's 10 plus y is equal to 40. And then if I want to solve for y, I'm just going to subtract 10 from both sides. So minus 10, minus 10. Y is going to be equal to 30. So if the side lengths here were 5, then y must be equal to 30. So that's all we're doing. Let's do it again for the next one. If they were 15, so that would just be, and this time instead of writing 15 plus y is equal to 40, I'm going to start writing it instead like 2 times 15. Same thing, right? Just 15 plus 15, 2 times 15. And then we're going to do the same thing, so that's just 2 times 15 was 30. So y is going to be equal to, I'll let you guys do that, 40 minus 30 is 10. So if these were 15, y would be 10. Last one, if the kennel were 12 meters wide, so same thing, just have our equation, 2 times 12 plus y is equal to 40. Y would end up being equal to, maybe I'll write this one underneath so you can see it, 2 times 12 was 24, plus y is equal to 40, minus 24, minus 24, y is equal to 16. Alright, so we can figure out what y is if we know these side lengths just by putting it in the formula like that. Now though, it says write an equation in terms of x that defines the area of the kennel. Okay, and before I do that, what I'm going to do is I'm going to draw another picture here of our fence. So we've got this side, and this side, right? And this was like the house right there. What I'm going to do is I'm going to call this side x, and I'm going to call this side y. So this was the width, so like it'd be 12, and the length was the y value that we kept on getting out, so 16 in that case. So what I want to do though is first make an equation for what we've been doing up here. So I want to make an equation for y. So what I'm going to do is say, I'm going to kind of copy what we had here, right? So if 12 was my x and 40 was my y, then this was just 2x plus y is equal to 40. And that makes sense too, right? I'm just adding up all of my fence to equal the total amount of fence, 40. So This 2x comes because there are two sides. There's, oh, not two. There's one side here and there's one side here. So we have two of those x's. And we have one y. Oop, weird. And we have one y. So two of the x's, one of the y, that equals 40. So that's all that's happening there, right? Now if I rearrange my equation like I've been doing up here, if I subtract 2x from this side and subtract 2x from that side, my equation for y simply becomes y is equal to 40 minus 2x. Okay, so we're going to remember that. That's like step number 1, we know that. Step number 2 is, this one's saying write an equation in terms of x that defines the area of the kennel. Well, I know that area is equal to length times width, right? In this case, I'm going to call area x times y, right? Because that is just length times width. I'm just using x and y as my variables. So x and y, that's my area, right? So that's my new equation. So it's saying it wants an equation for area. So the simplest equation for area was x times y. But it's saying in terms of x. We want to have this in terms of just x. So this one's good. That's in terms of x. I don't want a y in there. I don't want a y in my equation at all. So what I got to do is write that in terms of x. Well, luckily, I've already just made an equation that is just in terms of x. So y was equal to 40 minus 2x. So what I'm going to do, instead of writing a y there, I'm going to say area is equal to that original x that was there. But instead of having a y value, what I'm going to have instead is this. I'm going to have what y is equal to. So 40 minus 2x. Same equation, I've just replaced y with that, because that's what y was. Okay, so I've got that formula now. Now what we can do, that's the hard bit. So once you get that figured out, you guys have done this next part. So it says graph the function. So all you need to do is plug this into your graph. If you want it, you can plug it in just like this, or we can expand this. If you went x times 40 and x times negative 2x, what you'd end up with is 40x minus 2x squared. If I rearrange that to write it like you properly should, like have the x squared in the front, what I'd have is negative 2x squared plus 40x. So that, and then you could say plus 0 at the end to make it look like totally the way we've been doing it. So you could, either one of those, you could put that into your calculator or that into your calculator to graph it. And then when you graph it, okay, so I'm going to put this into my calculator. So I'm going to put this one into my calculator. You could also put the bottom one there, the minus 2x squared plus 40x. I'm going to put this in. There we go. So I'm going to go x. And now, if you go x and then just start a bracket, and then go 40 minus 2x, everything looks really good there, but what happens if I push enter now is it says, can I accept change invalid input? This one kind of messed with me for a second too. What you need to do in your calculator is you need to go x and then hit times. So it needs to be x times bracket 40 minus 2 times x. And that little, remember that little dot there, it's really hard to see in your calculators. That's that means times. So if I do that and then go enter, now it's going to let me. So next thing you need to do is figure out what my y window needs to be, because like right now you can see this thing is going like pretty straight up and down. It's going to go a lot higher than 6.67, and the question is, how high is it going to go? What you might want to do as a reference, go back to your original questions here, and these were the kinds of areas that, or no, not that, sorry. What we're going to have is these kinds of numbers for y of 16. So 16 times 12, that would be the area of that one. So we're talking about things in like 100 to 200 range, right? So let's make our y value around 200, because that's going to be more in the right ballpark. So if I do that, I go menu, window, Windows settings, my Y max, not 6, but more like around 200. And we're kind of getting close to the top, but we also don't have our value on the bottom, but it looks like we're about halfway there. So I'm going to make that around like 30 maybe for my X max. So window. So I'm going to make my Y max 250, let's say. And then my X max looks like it needs to go up too. I'm going to make that 30. There. So now we have a graph like you guys are used to. And we just need to find... Oh, I can't grab that. There. Oh. There we go. So it's saying, do we have a maximum or a minimum value? Well, we have a maximum value, which makes sense, right? We're trying to get the maximum area. So remember the y-axis here is our area. And our x-axis is going to be our x value there. We said the one side of our fence. Okay, so all you need to do is graph this function on this. I'll let you guys go ahead and do that. And this next question here says, do we have a maximum or minimum? What does the ordered pair of that value, or what is the ordered pair of that value? What do those two numbers mean? So if we find our maximum, menu, analyze graph, maximum, go to the left, go to the right. I got 10 and 200 are my two values there. So 10, that means the side length of our thing was 10. So if this was our house, we had our kennel, that means that this side length was 10. The Y value of 200, that means that that's our area. So our area here would be 200 said, right? 200. So side length 10, area 200 is what they stand for. Last one says find the x-intercept of the graph. What does it mean? Well, the x-intercept of the graph, if you think about it, the x-intercept is going to be when the area, so the y-axis, is equal to 0. So what would that mean? Well, maybe it'll make sense with a drawing. So if this was our last situation, this was our maximum area, right? If we made this any bigger, our x value, if we made 10 any bigger, what's going to happen is you're going to start to get more of a stretched out shape, right? It's going to look more like a rectangle. So that's getting closer to the x-axis. Even closer to the x-axis, you're going to get, even more of a rectangle, because right, that should be longer though. Even longer. Our x is getting longer and longer. But then as we get longer and longer, our area keeps getting less and less, right? It turns into more and more of a straw until you've got like really, really skinny thing with just a tiny little area in there, until we have absolutely no more area left. We just have like a straight line. That's what our x-intercept is doing. So so when the area is completely 0, what is the length of our fence? And just a heads up of what the length of our fence would be. Let's check out what it would be actually. Let's do that. So let's go menu, analyze graph, 0, go to the left of it, go to the right of it. That makes sense too, right? So it's saying x value is 20. So what that means is that there is absolutely no side length here at all. It's all this side. So it's this side times 2. So it's going to be 20 times 20, which is our full fence, 40 meters. Okay, so last thing here says, how would the equation change if you now had to use all 4 walls of the fencing? So now we've got a fence like that. It's not attached to the house. So now we've got, well, our original equation for y, remember, came from this. It came from going 2x plus y was equal to 40. But now that's no longer the case. Now we've got y there and y there. So our new equation becomes 2x plus 2y is equal to 40. So if I rearrange this to solve for y, then I'd have, here, I'll do this. So I go minus 2x, minus 2x. This would turn into 2y is equal to 40 minus 2x. So this 2 is the only difference from last time, right? And then last thing we gotta do is divide both sides by 2. So divide that by 2. and divide that by 2. So y is equal to, and what we can do is just divide the top and bottom by 2. So we're going to divide this one by 2, which cancels with that. And then 40 divided by 2 was 20. So this turns into 20 minus x. So that's our new equation. Now our equation for area was equal to x times y, right? Area is now equal to x times 20 minus x. So yeah, that's how our equation would change this time. Okay, so that's all I'm going to do for that one. I'd like you guys to... actually, I'm just going to end that video there. I'll do another short little video on the first one there, and then... yeah, we'll leave it at that. Okay, so we'll end that one there.